Okay. In case of like database space, you will see that in one side you will see a strong data consistency, SQL interface, which is easy to adopt. Experience point of view is very good because developers are familiar with these things. And other spectrum, you see that you have NoSQL. It's offer like scalability, availability, but you need to adjust your application and maybe compromise with your data consistency and all these things. But what I like most about CockroachDB, they combine these things together with other different features. We work together to build with them. So I came to know about CockroachDB from one of my colleague who is also an enterprise architect, right? Me in the same group, and he discovered CockroachDB by reading Spanner and other mechanism, and I came to know about CockroachDB from him, and since then, it's around like 2000, end of 2016 or something like this. We work very closely with Cockroach team to build different features in CockroachDB. One of them is like geo-partitioning. The other things I work pretty closely with Cockroach Labs is like CDC, the change data capture mechanism. And Kindred is a gambling company, online casino, betting, sports betting company. And we have around like over, I think, close to 25 million customers, and we operate in different market based on local license like Australia, Belgium, Denmark, Estonia, France. EU is our core market. We have around like 200 plus microservices, and it's like more than 35 million transactions we deal daily basis. And we have around like 1,400 employees, over 50 nationalities in 11 countries. I think we have offices together. So it's a big company, I would say, in terms of revenue and all these things. And we look into like different database solution during 2015, 2016, around this time, to meet these data challenges, global data challenges. And when he said global data challenges, it means that these are the three main things for very important to us. It's like compliance, latency, and resiliency. Compliance is important for us because of like GDPR, as Armand mentioned about GDPR. So this is really, really important for us that EU data does not leave EU boundary, and that's really, really important. And it's also important for us for our internal corporate governance and all this point of view as well. And we were looking for a solution that is operationally manageable, sort of like you can do it, but it will be very crazy way of doing with the traditional database solution that we have in the market. And it comes with a lot of operational complexity. We also want to improve the customer experience. We want to give them almost close to like near real-time experience in their gaming, bet placements, and all this like stuff. You see here that we have like a license in Australia. So at this moment, we have current state is we have a data center, operational data center in Malta. And if someone log in from Australia, we need to make a continental round trip to request response flow. So it's not a good customer experience point of view. So we want to improve this latency. Also, resiliency point of view, that since our operational DC at this moment in one single place, if something goes down or something disaster happen, it is not a good place you want to be. It is like, it may be end of the business altogether. So we do have the data backup, but you need to be kind of like bringing into live and make all the application migrate into DR side is a very time critical things stuff for us. So that kind of challenges we need to meet, and we looked for a database solution because we don't want to shift the burden to the application developer. We also not want to overburden our operations team to do a lot of crazy stuff in the platform point of view. And yeah, if we can meet the regulatory requirement, that's good if we get a solution like this. So this is an alternative, expensive, complex data distribution strategy if Cockroach is not present in today's scenario. Imagine that CockroachDB is not there. And we basically, we have like Oracle backend, and Oracle is our main storage system. We do have like Couchbase and MySQL for other stuff. So it is a bad shape if something goes wrong in Malta DC, because our RPO and RTO is not that great. So you probably know about like RPO is recovery point of objective and RTO is recovery time objective. So our RPO is not defined and RTO probably will take couple of, more than 3-4 weeks to come back in an operational stage. So this is not a good shape. And the thing is like, this is the model, probably the one options to overcome this scenario, like you have like active, passive storage system. But this is still a failover scenario, like you fail over to passive and do this all manual, unreliable process. And to do these things, also complying with the regulations is very tricky situation. The other thing is like with the active passive setup, is really this stuff is we tried. It's better to say we tried, but we actually couldn't actually make it work because we found it is very hard to test. It's brittle and it's from reporting, data consistency, integrity point of view is very complex to make it perfect and make it happen every time if something goes wrong. And then other issues is mentioned also, like it's reduced latency, requires complex replication of data, wasted of resource, limited serialization of transaction. So the other thing is good to note here is that if you go with this model like active passive, you have like 100% active storage. Then you have to keep another 100% passive, which is basically doing nothing. It's not actually, it's just waiting something goes wrong to take over. But then you don't go for 100%, you have to put some buffer, so it make it like another 130%. Then you have to make the passive also 130%. So it's like keeping you have a car to do daily shoppings or move around. You also keep another car in the same stage in your garage, in case like, yeah, your active one is broken. So it's just a wasting of your resources, basically. That's also another thing. So we want a solution in which that we actually use all the resources to serve our customer. is not actually ideal or sitting for something go wrong. So with this, we landed in CockroachDB, and we found it like CockroachDB can act like a virtual DB for the global transaction, and it basically simplifies the application and our service layer in terms of like operational point of view, data migration. If you want to move away from Oracle to CockroachDB, and also like scaling up, scaling down, in case like if data center goes down, we still will be able to survive because of the replication protocol, the raft protocol, which is like very is a proven protocol and is well implemented in CockroachDB, and we can rely on them because the core engineers of Cockroach labs, they already spend quite significant amount of their time building this large scale distributed system in Google environment. So they know what they are doing and they're good at what they do basically. So we can trust them. And the other thing with CockroachDB, but in particular like Cockroach Labs, like they're very, very transparent in their work, and it's very, very clear that what they are trying to do, what is very important for them for phase 1, phase 2, phase 3 in kind of like in terms of like improving the product cycle. So they basically focus on the correctness part of the database, and that is really, really important. You cannot actually go fast and lose data. That's probably not an ideal scenario. You also cannot go fast, have a corrupted data. That's also not possible. Like it's in financial regulatory environment, it is not an option for us. So they put all their effort to make sure that data is consistent, correctness is ensured, and all these things. And then they focus on the performance. And it also makes sense. Like we also provided a lot of feedbacks to the Cockroach Labs in terms of like performance, in terms of like different use cases and all these things. And they build product according to our use cases. Of course, they have other customers as well. So they also taken their view as well. But the important bit over here is that we got a solution, CockroachDB, which can actually help us to meet those data challenges that we have initially. With Oracle, with traditional database storage database system like Oracle, MySQL, Couchbase, and all this stuff, things can be done, but it's really, really tricky because I'm an architect. I don't do a lot of hands-on stuff, but in my personal project, in my POC and all these things, I try out CockroachDB, and it is really, really easy from my own Mac to all the way to production because it's a single binary. Like you can run the same binary in Mac. You can take the same thing and run it in your production data center. Of course, you have to think about like security and all this stuff that you don't have to worry about in your personal MacBook. I can give you another example, like Arman mentioned about like CDC. We do have like Oracle, and with Oracle to have the CDC, you need another product called Golden Gate. And that Golden Gate also, you need an extra bit of license to work with. And you don't have, you need to talk to your DBA to set up the Oracle and the Golden Gate, and you don't have the visibility, whether it's how it is being configured, how it is working, and all these things. With CockroachDB, and particularly I work with the CDC features together with Kai, you just need to execute one SQL command, and it change feed, they call it change feed in Cockroach world. CDC world, and it starts. And I can go to the admin UI, I can see that whether job is running, what is the status of the job, what are the different metrics, that how many messages being produced, how many bytes is being published, on all these things, good stuff. as a developer, that makes life more comfortable than talking to a DBA team to configure stuff for myself. So it's like why I'm saying these things is very operationally is very they have simplified many different things, and which is I found it personally quite helpful. So if a data center goes down, and as you mentioned, like in our use case, like Kindred, we have like one operational. We do have other data center to run our data analytical platform. But if our operational data center goes down, we'll be in a bad shape. But our goal is to build at least 3 data centers in Europe, which is we haven't reached there yet, but we'll be there soon. So 3 data centers in Europe, and we'll go with 2 data centers in Australia, and then we have like our US market. We also plan to expand quite significantly to meet the US customer needs. So from our business point of view, we need a global data service basically to serve our customer, and it should be resilient. In case of like failure, data needs to be, we cannot lose the data, and data should be distributed in other active nodes. And all the data center, there is no DR is happening here, there is no failover. All the data centers are active and they are serving the customers. And if in case the one data center goes down, we can rely on the CockroachDB resiliency property to make sure that we still can serve the customer. So it means that our core market should be able to make forward progress in case disaster happens. So that's one of the criteria set out by our tech management, that we should always make forward progress in case of disaster. So these are the value adds I can see from CockroachDB, our users of CockroachDB at Kindred. Like we already mentioned about these things. We don't want to go, that's another important part over here is the active passive thing, is that you probably can have active passive stuff in different geographical location, and then you probably can attach a traffic affinity based on different market to those active passive setup. But that will create a data silo. We don't want to have that data silo in place. So we try to avoid the data silo, and that will actually improve our operational organizational efficiency. And we want a logical database where the global invariance, application invariance can be ensured. Like we can say that during the registration time, if whether is a customer is being registered with our system with this service, even though I'm not sure whether you know that how CockroachDB works in sort of like read-write path. So when you go to the right path, it requires a quorum to ensure that consensus and all these things. During the registration type, we can ensure like global invariance, saying that, hey, find it out whether this customer is already being registered or not. So we don't mind to pay the latency in this use case or scenario. But in terms of like gameplay, transaction, deposit, placing bet, it can be tied to the local read-write path. So Australian customer transaction does not need to travel all the way to the Europe to make that write happen. You need a quorum to make it happen, right? So it doesn't require. Why it is not required? Because we are using the geo-partition. Geo-partition is a key enabler for us to do all these things. It's not only like regulatory stuff to meet the regulatory requirement, it also improving the customer experience stuff. And in case like if a customers move from one geographical location to another geographical location is something called like data follow the user, like workload gets moved to where the customer gets moved. So these are the good properties of CockroachDB, that you don't have to do anything specific based on like write or read workload pattern. It moves the data where it is actually seeing the most of the traffic is coming from, and that's also good features. And the compliance, I talk about like compliance GDPR, and with the US, US is very complicated. US, in case of like US in the gaming side, New Jersey, for example, you cannot move out from the New Jersey. You cannot move the data from New Jersey state to some other state. And different state have different game data requirement, like Pennsylvania, California, they have their own way of dealing the data. So this is actually key properties we'd like to have in our database system, so that our developer don't think about this kind of like complexity in their application code. They just purely focus on the business logic side, and that's really important. Performance, I talk about performance, so this kind of like follower reads and all these things are really quite useful. The other stuff like operational simplicity is very, at least our DBA is now saying that they are okay with CockroachDB because they found it quite easy to use, because you'll definitely find some diehard like Oracle people, MySQL people, and convincing them is like you need to influence them, and this is one of the influential factor, like, okay, how simple it is to run, how simple it is to deploy, and how simple it is to manage when it is in production. So this is also good properties, and to sell to the application developer, this is one of the important criteria, that is standard SQL and PostgreSQL compatibility, so that they don't have to learn a new API to move from Oracle or other existing storage system to the Cockroach layer. And Cockroach CDC, yeah, I like it. Basically, there are so many things we can do with Cockroach DB CDC, which will be quite difficult to implement without these features, like data migration, like analytical use cases. Like you at this moment, CockroachDB is OLTP database, but maybe at one point it will become hybrid analytical transactional processing solution. But now what we can do is like we can enable the CDC, we can get the data out of the database quite nicely without writing any crazy ETL, PL, SQL code, and it goes straight to the Kafka, and from Kafka we can actually push to wherever we want. At this moment we do use AWS for our analytical platform. We can straight go and write to the S3, and it is quite nice to have these things in place. And it is also good, like CockroachDB is distributed SQL and Kafka is a distributed commit log. So it goes like in parallel. It's quite nice to work them together. So this could be a next talk, maybe, if I can talk. So we will talk about like CDC, how we use CDC with Apache Kafka, and it actually plays a quite, it will play a good role in our new messaging model. So today we use like JMS, Solus is pretty hardware appliance, and we cannot run Solus hardware appliance in cloud environment, and we can use Solus software version, which is VMware. But VMware is not as reliable like their hardware appliance, and this requires a new thinking process around like how you deal with the messaging, because we need to do a lot of service to service asynchronous communication and also data flow towards our analytical platform, and we want to reduce the number of integration, and this is one way we will be trying to reduce this level of effort together with Kafka.